In this video, we're going to look at the difference between type 1 and type 2 errors, which comes up all the time in hypothesis testing. The key definitions are that a type 1 error is rejecting H0, so rejecting the null hypothesis when H0 is true. And a type 2 error is accepting H0 when H0 is false. So accepting the null when the null is false. And the type 1 error is generally known as a false positive because we falsely claim that our test is significant. We falsely choose H1. And type 2 error is known as a false negative because we falsely reject H1. Okay. In general, type 1 errors are often seen as worse. The common sort of thing that is compared to is a type 1 error is like condemning an innocent man in a court trial. So we reject H0. H0 is our innocent man, that should be our sort of prior belief, but we're rejecting that even though he is innocent. And using the same sort of analogy, a type 2 is the idea of letting off a guilty man. That's sort of a real life equivalent idea. Now, the probability of a type 1 error is the probability of reject H0 given that H0 is true. And that is actually what's known as the significance level of a hypothesis test. So if you're carrying out a hypothesis test at a 5% significance level, that means you have a 5% chance of rejecting the null when the null is actually true. Okay, so let's have an example of actually working out, an experiment, actually working out what the probability of type 1 and type 2 errors are. So, e.g., a box contains either H0, one white counter, and 19 black counters, or H1, 10 white counters and 10 black counters. A test is proposed draw 3 counters, if all are black except H0, if not all black, reject H0. The idea being that in the H0 case, there's a lot more black counters than white counters, whereas in an H1 they're equal. So if we draw 3 counters and they're all black, we think it's likely that H0 is true. So let's find, in this example, for this test, what is the probability of type 1 error? Well, let's remember that's the probability of rejecting H0 given that H0 is true. And so what's the probability I reject H0? That means there must be at least one white counter drawn when H0 is true. So that means we don't draw all black, so it's 1 minus the probability 3 black counters drawn. And what's the probability that 3 black counters are drawn when H0 is true? Well, it's the probability the first one is black is 19 over 20. The probability the second one is also black is 18 over 19. And the probability the third one is black is 17 over 18. Sort of, if you're familiar with probability when we don't replace the counters. And if you work out this probability, I think you get 1 minus 0.85, which is 0.15. So the probability of a type 1 error is 0.15 in this case. Let's figure out the probability of a type 2 error. This is, remember, this is the probability we accept H0 when H0 is false. So this is the probability, in our example, it's the probability that this is the probability that I draw 3 black counters drawn, given that H1 is true. So what's the probability I draw 3 black counters when H1 was true? Well, H1, I started with 10 white counters and 10 black counters. So this is, well, the probability the first one is black is 10 out of 20. The probability the second one is also black is then 9 black counters left out 11. And the probability the third one is black is 8 out of 9 out of 19 over and 8 over 18. And if I do this multiplication, I get 0.105. So my probability of a type 1 error is 0.15. My probability of a type 2 error is 0.105. In general, it's hard to reduce both of those errors without doing lots of tests. There's often a trade-off between type 1 errors and type 2 errors. If you have a high probability of type 1 error, you might end up, if you have a low probability of a type 1 error, it might lead to a high probability of a type 2 error, and vice versa.